We'll answer few more questions. We'll discuss few more questions of this type. One question says, successive emission of an alpha particle, one alpha particle and two beta particles by a nucleus. If an element loses an alpha particle, it goes behind by 2 units, and then the mass, of course, it goes loss of 4 units in the loss of one alpha particle, but the position wise it goes back to 2 groups behind, and 2 beta particles will advance that element. The element will move forward by 2 units, or in other words, the element will come back to the same position. Therefore, the successive loss of an alpha particle and 2 beta particles will lead to the formation of the isotope of the element, because 2 units, 1 unit of alpha particle will go back by 2 units and 2 beta particles will go forward by 2 units, so that the element will come back, the nucleus will come back to the same position. Only thing is the mass will be changing, and therefore will lead to the formation of the isotope of the element. So that is the answer for this question. Isotope of the element will be formed. The next question says, the number of alpha and beta particles emitted in the reaction. A reaction is given, a nuclear reaction is given. Thorium 228 of atomic number 90 leads to bismuth 83. What is asked is, how many alpha particles and beta particles are being lost in this process? Now, when you look at that mass values, it is 228 and 212. The difference is 16. 16 corresponds to 4 alpha particles, because mass of an alpha particle is 4 units. Therefore, 16 must correspond to 4 alpha particles. Now, in terms of charge, you will find 4 alpha particles means 8 charges, 4 into 2, 8 units must have been lost. But actually here you find only 7 units have been lost from 90 to 83. Therefore, 1 beta particle. The question asked already is given there. How many alpha particles are there? We already fixed up 4 alpha particles, because the mass goes down by about 16 units. That means 4 into 4, 16. 4 helium nucleus. Now the charge must correspond actually to 8 units. If it is simply the loss of alpha particles, it should go down to 82 actually, but it is 83. Therefore, there is 1 beta particle which results in the increase in the atomic number. Therefore, the number of alpha particle is equal to 4 and the number of beta particle is equal to 1. So 4 alpha particles and 1 beta particle has been lost in the process in the conversion from thorium 228 to bismuth 212.